This is a short video to introduce the idea of scalar and vector quantities. Now, some quantities such as time and temperature and mass and density and so forth can only be described by just a number, a single number, with a unit. For example, we have time of, say, 1 minute or 60 seconds. You have a number here and unit. Or we have a temperature T of, say, negative 10 degrees Celsius. Again, a number with a unit. Or mass, like a mass of an object of, say, 10 kilograms. Again, just a number with a unit. Scalars can have positive or negative or even zeros. But many other quantities have a directional quality that cannot be described by just a single number. For example, if you are driving down the road in a car, say at 60 kilometers per hour in the north direction, then you're not just specifying the number or how fast you're moving, but also you're telling me the direction. Quantities that have both magnitude, which is like the size, how much or how big, think of it like a magnitude of an earthquake, and also a direction, are considered vector quantities. So we say vector quantities have both magnitude and direction, whereas scalars just have magnitude only. Examples of quantities that are vectors are velocity, which will be introduced later, say 60 kilometers per hour north. I'll put the direction in brackets here. Or say force, like 6 newtons in the down direction. So there we have magnitude and direction. Or say the displacement of 100 feet in the northeast direction. All of these have both a magnitude and a direction, and they're categorized as vector quantities. When we want to represent a vector quantity, we need to make sure that it's different from a scalar. So we need to use a symbol like velocity v, but we need to make sure it's distinguished, say, from like a speed. If I wrote just speed of, say, 60 kilometers an hour, I'm only telling you the magnitude here. But if I tell you the magnitude and the direction, I need to distinguish between these two. So what I do is I put an arrow above the v to represent and show that this is a vector. In our handwritten work, we draw arrows above the symbols that are vectors. Otherwise, we'd be confused. Some textbooks will represent vectors with a bold face. They'll make that V look really dark, but I would like you to consistently display your vectors with arrows above your symbols. So we can represent, for example, force, F, with a vector, or displacement delta x with a vector. Now you may notice that often I will draw, instead of writing a full-size arrow, I'll draw a half arrow because it's just quicker to draw the arrows, and that's okay if you want to do that as well. When we solve problems later on in the next chapter, we like to visualize the problems, and one of the first things I will do is I'll ask you to draw a motion diagram. Basically, it's like you have a camera and you're taking still photographs at different frames of time. So for example, I'm going to draw a car here moving down the road at a speed of 20 kilometers per hour, but I want to indicate the direction, so I'm going to draw an arrow here like this, and we're going to label this as, say, v sub 1. So this is the velocity at this point in time, say t1. Over here on the right, I might indicate, say, to the right is in the easterly direction. So now I'm indicating not only how fast it's moving, but also the direction, and hence we're giving the velocity. And you'll be introduced to this later. Speed, by the way, is just how fast you're going. Velocity is how fast, but what direction you're going as well. So it's how fast and what direction. Let's draw a second picture here of the car, but at a different time, a little bit ahead of time now. And now I'm going to show that the car is moving a little bit faster. So I'm going to draw an arrow, but look at the arrow now. There's my arrow, and this is my velocity 2, which is, we'll say, 60 kilometers per hour. Now, if you look at this arrow and you compare it to this one, I hope you'll notice that the faster speed has the longer arrow, which basically means that the length of the vector is proportional to the magnitude, the size, or how fast in this case the vector is. I've drawn this arrow approximately 3 times as bigger as this one, because it is 3 times the magnitude of that arrow. So we use arrows in our motion diagrams to represent vectors. The direction of the arrow tells you what direction the car is moving. And the length of the arrow tells you the size of the vector, or the magnitude.